Hi and welcome to another logic video. Today in this video we're going to solve some more exercises using the last rule we had covered, which was universal quantifier introduction. In this exercise, in this example, we noticed that we want to prove a universal quantified sentence, and we know that in order to do that, a good strategy, of course, is to assume the something that matches, something that satisfies the restriction of this universal quantified sentence. We have to watch out and make sure that in the place of x we use a constant letter that doesn't appear anywhere before. So this would be an assumed premise for the purposes of doing universal quantifier introduction. And now once we have this, we notice that 3 and 4 have an implication, which is the following. And then we, by the way, what is it that we aim to achieve at the end of this subderivation? We started at line 4. What we aim to achieve is CA. Okay, let's keep that in mind. We want to go to CA. Okay. Now, the next step is to notice that line. In order to get to CA, we're going to have to make use of the first premise, and in order to do that, we have to acquire something that matches its restriction. And particularly if I want to get CA, I want to get the conjunction of AA and the universally quantified sentence that follows AA in a conjunction. So my goal then should be to try to get this quantified sentence. It's a midterm goal for me. Okay, in order to get that, in order to achieve this, I should make an assumption for its an assumption of its antecedent using a new letter. So BB is what I'm going to say. Now AP for another UQI. This is a separate UQI job. Now BB and 2 together will imply DB. And now if you look at 5 and 7, you'll notice that RAB follows from these. 5 and 7, universal quantifier elimination. This is how I would actually finish proving this universal quantified sentence that I had wanted. 6 to 8, universal quantifier introduction. Remember, I still have my main goal was to get to CA. Okay, so make a conjunction out of AA and the sentence I had just proven, and that would be 4, 9 conjunction, and this allows me to conclude CA, right? 1, 10, universal quantifier exploitation. And this is how I would eventually end up proving that all A's are C's. Okay, this is a little bit longer. The thing you notice immediately here is that we should assume something that matches the antecedent. But then if I assume FA, that will clash with the A I already have in the premises. The rule is not to do that. So let's not do it with A. Let's do it with B, which doesn't appear in the premises. So this is an assumed premise for UQI again. What would be the thing I want to prove at the end of this subderivation? It's something that matches the body with B in the place of X. Okay, but that is also a universally quantified sentence, and to prove that I should make another assumption using another new letter with the quantifier phrase here, with the restriction of that sentence. And so this is another AP for another UQI. And now, of course, I have several routes that open up. 3 and 5 imply that 3 and 5 with UQE imply RBA. Now, notice that 2 is going to be relevant here a lot. Okay, so let's start like this. If we make a disjunction like this from GA by addition, then we are able to prove that HA from 2 and 8 UQE. This is 8, this is 9. Now that would allow me to do something, right? I don't know if you noticed this, but right here is an existentially quantified sentence as part of the first premise, and notice how I can infer something that I can use together with that later. This sentence follows from 7 and 9 with existential quantifier introduction, obviously. And now, if only I had HB as well. Now, I can get HB. All I have to do is first make another use of the addition rule, FB or GB, from 5 addition. That gives me HB from 2 and 11 UQE. And now I can put together HB and line 10. Okay, so 10, 12 conjunction. And now I'm able to use this line 13 together with 1 for universal quantifier exploitation, which would get me this result. All z's are BZ. Okay, now this is a step closer, of course, but I'm going to also need HC. Now, since I have GC, I can write if C or GC from 6 addition, and this would give me HC from 2 to 15 universal quantifier exploitation. I'm going to continue over here with 17. RBC follows now from these, from 14 and 16, with universal quantifier exploitation. Okay, which allows me to prove the universal quantified sentence I wanted. And finally, the conclusion, you can copy it right here. Voila!
Made with Doodlecast Pro.